All right, so we are starting 8.1 polar coordinates, which you guys already did your intro to that. And by the end of today, you're going to be able to define polar coordinates and understand how they are related to rectangular coordinates. Well, when I say rectangular, I mean on the coordinate plane, okay, the XY plane. And now we're going to start to introduce a new plane called the polar plane, and we'll get more into that tomorrow. The first thing we're going to talk about are the polar coordinates, r to theta. So r is going to be the distance from what we call the pole or the origin to the point P. And then I do want you to put those brackets on them. So that's how we're going to distinguish polar coordinates from rectangular coordinates, is we're going to have these brackets. Theta is going to be the angle measure, theta. We have the polar axis. And then if we have negative values, what happens is they end up being pi units away from the theta value. So anytime they're negative, you can think of it as a reflection. So let's take a few more notes on that, and then I'm going to show you a quick example. So theta is positive if you're traveling counterclockwise, negative if traveling clockwise, which we already know from being able to graph on the unit circle. If r is negative, then you would go r units from the pole in the opposite direction. Okay, so the opposite direction is going to be pi units away from your original theta value. So I said, look at the picture on page 542 and draw it to the right. So here's my drawing. So here's your center. Here's your pole. Okay, and then your theta value. Your point P would be r theta. And then if this was a negative value of r, it would be your theta plus pi. Okay, so it would be the reflection of that point. So I'm just going to show you with a different example real quick. So if you were going to graph pi over 2 for a given positive r value, pi over 2 is of course a 90-degree angle, right? Okay, so to graph this point P, your point P would be whatever your r value was. Let's say it was just 1. 1 pi over 2. If your r value was negative, okay, it would be a reflection. Okay, so if you had a negative value, if you wanted this same place, it would be negative 1 plus pi over 2 plus pi. Okay, which would end up being what? What's pi over 2 plus pi? 3 pi over 2. Okay, because if I go to 3 pi over 2 and then I go the opposite direction, I would be right here back at P. Okay, or if it was pi over 2 and I had a negative 1, this would be Q. So this would be negative 1 pi over 2. Okay, in the opposite direction. So these are two different points. This would be 1 pi over 2. This would be negative 1 pi over 2. Okay, if you wanted to write the same point, that's where you add in theta. And again, that's because they're directly across the circle from each other. All right, we're going to look at example 1, and then we're actually going to go back to what we did on our packet. So for example 1, you're going to plot the point that has the given polar coordinates. So the first thing it says is that r is less than 0. Which, if r is less than 0, then that means the r value is what? Negative. Okay, so one has to be r is less than 0. The other one has to be r is greater than 0. So basically what they're saying is one of your r values has to be negative and one of your r values has to be positive. So I've laid out the steps here for you. You're going to draw the polar axis in the origin or the pole, rotate to the given theta, and then we're going to label the drawing. After that, in step 4, if you're finding two other points, you're going to add and subtract 2 pi for the given value of r. Okay, so you're always adding and subtracting 2 pi for the given value. For the next point, you're going to replace r with the opposite. Okay, so whatever the opposite is, that's when you add or subtract pi. All right, so we're going to start with a, 1/2 and then 5 pi over 6. So 5 pi over 6 is really close to what? Pi, right? We know it's approximately how many degrees from pi? Okay, so then I'm going to start, and you are going to want to give yourself room, so don't take up your whole space here. So what I've done is step 1, right? I drew my polar axis with the origin. Now it says to rotate to the given value of theta. Okay, so I'm going to estimate where that is, approximately 30 degrees up from a straight line. Okay, and then I'm going to go ahead and label this as 5 pi over 6. And now I have to label my point P, which would be right here. And then P is going to be 1/2 5 pi over 6. Okay, so that was steps 1 through 3. Okay, so I've labeled everything on my drawing. I have my origin, my point, and then my theta value. For step 4, it says to find two other points, you're going to add and subtract 2 pi to your given value. So this is step 4, and I am given that my r value is positive because it's positive 1/2. So what I'm going to do is add 2 pi to my theta value. So I have 1/2 5 pi over 6 plus 2 pi, or you could do 1/2 5 pi over 6 minus 2 pi. Now it says you only have to find 2 points, one with the positive. I'm going to go ahead and show you the 2 different ones because on your packet you found those 4 types, and that's something that you'll have to do on your test as well. So I want to make sure that we're relating those together. So if I'm adding 2 pi to 5 pi over 6, really I'm adding what? 12 pi over 6, right? So if I add 12 pi and 5 pi over 6, what do I get? 17 pi over 6. And then I can subtract. So 5 pi minus 12 pi is negative 7 pi over 6. Okay, so these would be my positive values of r. Okay, now I'm going to do r is less than 0. So for r is less than 0, that's when you're going to add or subtract pi. So if I have 1/2, I change it to the opposite, and then I'm going to have 5 pi over 6 plus pi, or I could do negative 1/2 5 pi over 6 minus pi. So if I'm adding or subtracting pi, I'm really adding what? 6 pi over 6, right? So I'd have 11 pi over 6, or negative 1/2 negative pi over 6. Okay, now a couple of things I want to mention is now when you look at these points, we can see they're the format of what we did on our packet. You had to find a positive positive, which is this one, a positive negative, this one is a negative positive, and this one is a negative negative. Now the reason why we add 2 pi to the first ones is because remember, what you're doing is you're trying to find another name for this point. So if you're finding another name for it, one way is to go around counterclockwise, which would be adding 2 pi, or if you subtract 2 pi, you'd be going around counterclockwise. Sorry, that wasn't very straight. Okay, and then for the negative, the reason why you're just going part way is because the negative would be here. So to get it back to this point, I have to either add pi or I have to subtract pi. Okay, so it's all about the rotation of the circle. All right, so we're going to look at the back page of your treasure hunt packet that you did. And we're just going to check to see how we did at finding these. Okay, so for B, point B is right here. So this could be 5 pi over 3, which is where it is. Remember that every angle has how many names? Okay, or I guess in 2 pi it has how many names? From negative 2 pi to 2 pi has how many names? What's another way I could label this angle? 5 pi over 3. Negative pi over 3, right? It always has a positive and then a negative counterpart. And if you were to add those two together, 5 pi over 3 and pi over 3, what would you get? 2 pi. Okay, because one time around the circle. Okay, so that's where this negative pi over 3 comes from. Now, if you have a negative 3, if I was at 2 pi over 3, my negative 3, or my positive 3 would be here. So if I'm doing the negative, what's happening is it's a reflection, and it's a reflection that's 180 degrees. Okay, so that's why you should have negative 3, 2 pi over 3, and then the negative name for 2 pi over 3 is negative 4 pi over 3. Because 4 pi over 3 plus 2 pi over 3 is what? If you added the positive version of this to 2 pi over 3, what would you get? 2 pi, because it makes a circle.
Like, is it easier, like, are you alright instead of doing, like, the 1/2, the coordinates plus 2 pi minus 2 pi, is it alright if you just do it in your head? You just kind of, like,
Oh, yeah.
Okay.
Yes, yeah. I just wanted you guys to have that, so if you look back and didn't know what you did. Yep. And then here's D. So for D, you should have 5, 7 pi over 6, 5, negative 5 pi over 6, negative 5 pi over 6, and negative 5, negative 11 pi over 6. Okay, so if you did this yourself and got these correct, that's an excellent, excellent thing to know how to do. Okay, that will really help you when we're going into the next couple sections. Okay, and then you were to pick any 2 points and give the 4 names for those. And I put my E here and my F here. Obviously ours are not going to be the same, so you're going to check yours for each one using that same method. I did want to mention up here the formulas that they gave you. So here you had R, and then it was theta plus 2 pi n, which remember, that's just like 2 pi k. So that just means it's a rotation around the circle. And then for this one, they had the opposite of 2n plus 1, which I know looked a little weird. So what I did is I distributed the pi so you could see how it's theta plus 2 pi n plus pi? So it's the rotation that you had before, but plus another pi, because it's directly across the circle when you have the negative. Okay, so I know that was kind of complex to understand, but I was hoping that the examples here that they gave you would help you with 1, 2, and 3, the examples that they gave here. All right, now let's look at part B. Okay, so for part B, we're going to start by drawing. Negative 4, 101 pi over 2. So I'm going to start with my polar axis. And then I really don't want to count 101 times around. So I want you to think of a strategy that you could use so we wouldn't have to do that. So I have my pole, I have my polar axis. said pi over 2, you said goes into something 4 times, but I don't know if you said, did you say 2 pi?
It goes into 2 pi 8 times.
No, you're right with the 4 times.
Just ask someone else. I totally forgot what that was.
Okay, that's all right.
Well, 100 divided by 4 would be 25, so you just add 1 to that's 26.
Okay, so the pi over 2 is 4 times, that's right. So there are 4 pi over 2 angles in 1 unit circle, correct? Okay, so if you take 101 and divide by 4, because that's how many you have, like Kenny said, there are 25 complete rotations with how many left over? Just 1, right? Or put 1 pi over 2. Okay, so if I were to rotate 25 times and then just go 1 more, I would be up here, right? This would be my angle, which would be at pi over 2. So I'm going to label this, but remember, it's negative. If it's negative, my point is not up here. Where does it go? It goes down, right? Then the opposite direction. So then I'm going to make my point in the opposite direction, which is negative 4, 101 pi over 2. All right, now if you look back at the directions, it says you want to use whatever the given value is to add or subtract 2 pi. So then you want to ask yourself, what was given here? Was it the positive r or the negative r? The negative r. So what's given for step 4 is r is less than 0. So that's what I'm going to add and subtract 2 pi to. So I have negative 4, and then if I do 101 pi plus 2 pi, what would I get? Do you guys want me to write it out, or is it okay if I just write what the answer is going to be? Okay, because 2 pi is the same thing as 4 pi over 2, right? So if I'm adding 4 pi over 2 to 101, I would get 105 pi over 2. Or I can subtract. So if I subtract 4 pi, I get 97 pi over 2. Okay, so, and again, that's because it was the given value. Okay, so even though it was negative, we added plus or minus 2 pi because that's what was given. So now I'm going to find the opposite, and the opposite would be the positive value. So I'm going to change negative 4 to 4, but then I'm going to add or subtract pi, or 2 pi over 2. Okay, so then if I add 2 pi, I'll get 103 pi over 2. And then if I subtract, then I got 99 pi's over 2. Alright, and then those are going to be my 2 options. And then again, I just want to stress that they're just telling you to find 2. I'm giving you all 4, so you can see how that setup looks in relation to what you did on your treasure hunt. Now for C, all of these are polar coordinates, which means this is still in radians. So your 1 value is in radians. So we are still going to do an estimation. So I want you to think about this when you estimate. Don't I know what radian value is a 90-degree angle as a decimal? Yeah, 1.57, right? Because it's half of pi. All right, so I know that this has to be in quadrant 1. So when I draw this, I'm going to estimate 1 to be somewhere around here. You can think of, if you cut this in half, right? Half of 1.5 is about 0.75. Okay, so that'd be about 0.77. So if you have this here, the halfway, you know it has to be more than halfway. So see how I'm using that reasoning to help me set up my picture? Alright, so I know it definitely has to be more than halfway. Alright, and then I have to label my angle, so that's 1. And then it's positive, so P is going to be out here. And then I'm just going to label that as 2, 1. Now, when you're writing out your final answers here, you're going to keep it as an exact value, which you're actually going to like better. So if it's an exact value, you are given, in this case, that r is positive, so you're going to add and subtract 2 pi. If I'm keeping it exact, then that means I'm just going to have 1 plus 2 pi, or I have 2 and then 1 minus 2 pi. Okay, and you can leave it just like that. And then for r is less than 0, when I do the opposite, I'm going to add or subtract pi. So I have negative 2 now, and then 1 plus pi,